We're doing last page. Where's Derek?
Derek's up here. Isaac? This is Isaac. Okay, eyes tracking me. Wait for 100% eyes. You have one, right? Out. Did you ever get one? You've never got one? Asia, did you have one on Friday too or no? Did you ever get one? Never got one. Okay. Raise your hand if you don't have your science journal right now. You need one. You need one. Yes, you need to make. Okay. Your favorite chain line? Yeah, this one. Write your name on it. Okay, now raise your hands if you do not have a science journal in your possession. Great. Then, for those of you that weren't here on Friday, fine, you should have your journal, that's great. And so everybody who does have their science journals and was here on Friday, when we were taking Cornell notes, please flip to the last page of our notes. Okay. So for those of you that weren't here, Aisha, Alessandra, we're going over how to take notes in class. It's important. I'm still going to be walking us through these notes, but for now, we can peek over to your shoulder partner, because your shoulder partners do have the notes down. That's the format we're going to be following. So if you notice, really briefly, that pink line, about an inch from the pink line, you're going to draw a straight line down. So about an inch from the pink line, just like she did here, you're going to draw a straight line down. Just leave that here. And so up here on the board, I have my miniature, or my actually enlarged version of your notebook. Again, this is my pink line. I'm just going to draw my dotted line to represent the solid line that you are drawing. Okay, so wherever you left off on your last page on Friday, you can either continue on the bottom page or flip to the back page if you don't have any more space, and this is what I will do. Today's a new day. I need all eyes tracking me. Waiting for 100%. Okay. So today, we're going to be going over matter. One more time, our objective for today is what kind?
Investigate and report observations to create information.
Fantastic. Okay, and as we're going through this, I want you to keep in mind the properties that we separated into different groups, as well as the demo that we went through together. So, what is matter? Again, I'm going to walk you through these notes to kind of help you out, to show you what I would write. I would write a title first of all, so we know we're starting a new section. The last section was what? Somebody raise your hand. Alma? Okay. So for those of you that couldn't hear, Alma said types of investigations. How do we know that those types of investigations? Aisha, I know this is you. Or, sorry, you don't need to. That was just me. You just draw. Okay. Erase that. So I can make sure you're following. Okay, so how did Alma know it was types of investigation? Because we titled it. Because we titled it from our last class. So, just like last class, we're going to title this one Matter, so that we know when we look back, what did we cover on August 21st? Matter. Crawling so we can run. Right now we're crawling. I understand. Good? Okay, so let us begin. Matter. On the left side of the page, Aisha, Alessandra, what we'll be doing here then is writing matter. What is matter? Okay. Everything. I would just put something as simple as everything. What does that mean? Amai? So, are my shoes matter? Is the food you ate this morning matter?
Yes.
Are you matter?
Yes.
Matter is what all things are made of. I heard a whisper about mass. We'll get to that. Matter has three forms. We covered these three forms last week, I believe, when we first started. And I think this class had a good handle on what those three forms already were. I see Isaac putting up 4 because he wants to mention plasma, but we're not going to be discussing plasma in class. So can someone give me 1? Juanita? Solid. Fantastic. So what do we have? We have matter. What is matter? Everything. Matter has 3 forms. Great. One of them is a solid. Number 2. Alexa?
Yes.
Yes. Okay.
Liquid.
Liquid. We have liquid. And number 3. All right, Alma.
Yes.
We have gas. So, quick pause. Aisha, how are we doing? We got matter. This is our definition on the left. And then on the right, on this portion, that's where we're going to be elaborating or building on whatever's over here. So that when you look back on the notes, go to the big space here, you'll see matter. What is matter about? Everything in three forms. Got it. Okay, so matter has three different forms. We've covered them perfect. Well, 4 plasma, what we looked at, liquid, and gas. What do we know about solids? What do we know about solids? Okay, we have some images up here. That's attendance. Isaiah. Here. Our taking attendance, just say here present. Aisha. Kai.
Here.
Alma. Alexa. Abram. April. Aranza. Celeste. Celeste. Diana. Celeste. Nicole. Alice. Layla.
Here.
Hillary.
Here.
Amaya. Isaac Alvarado. Jennifer.
Here.
Juanita.
Here.
Amanda.
Here.
Unique. Amanda. Daniela.
Here.
Noemi Alessandra. Darlie. Adam.
Here. Here.
Arlen.
Here.
Allison. Addison.
Here.
Isaac William.
Here.
Faith.
Here.
Gabriel.
Here.
Here.
Derek. Okay. Thank you for that. On to our notes. Here we go. We do move it quickly because we do have a lot to cover. So we have solids. A solid has its own shape. Yes, Aranza? The sponge is a solid. Yes, thank you for noticing the little puddle beneath this sponge. A solid does not change unless you cut, bend, or break it. Here's that last piece of information that I heard whispered that is important when it comes to matter. We'll see why in a second. Solids take up space and they have mass. So, in my notebook, if I'm taking notes on this slide, I don't need all of this information. I will take away the most important parts after. So we have matter. What is matter? It's everything. There's 3 forms of matter created. There's solid, liquid, and gas. What is solid? To build on this, what do I know? Solid has its own shape. And take up space and have mass. And I'm modeling these notes for you now, but as we progress, you will be doing this on your own. Step number 2, we have liquids. Liquids do not have their own shape. Liquids take the shape of the container. What does this mean? Isaac? That's not it. Okay, I see here viewed by the graphics. Here we go. So, we look at our pan over here. From my demonstration, or my cup here, if it was filled with water, the water itself does not have shape. Instead, the water would mold to the shape of my cup or the shape of that pan like it's in. So, if my pan was in the shape of a box, what shape would the water be in? Box. How does this differ from solids? And unique?
Liquids don't have their own shape.
Unique says liquids do not have their own shape. From our notes, we have that solids do have their own shape. So, I'm sorry. That line. Great. So liquids then have the ability to take the shape of their container. So take shape of container. Here's something similar to solids that liquid has though. What's special about liquids? They too take up space and have mass. So I'll translate those notes down here as well. Liquids take up space and have mass. Last but not least, we have our gases. Yes. We have our gases. Gases have no definite size or shape. Similar to liquids, gases can take the shape of the container. So we see this cool little soccer ball here. The gas inside of that soccer ball does not have a shape, it instead forms to the shape of the soccer ball and it becomes a sphere. Same thing with this rubber tire down here. What do we think it means by gases not having a shape? Unique?
Like if you split like apples right here, like if it's in the air, it doesn't form a shape unless you put it in.
Okay, so unique says if it's in the air, so if we look at a little tea kettle graphic here, we're familiar with tea kettle, what happens with the water or whatever liquid's inside, it becomes heated up to the point where the liquid inside evaporates and out comes this little poof of smoke. And while it may have a little shape initially, eventually it's going to reach the rest of the room and those little particles are going to go everywhere. There goes the shape and the shapes are lost. So no definite shape. A gas will fill all the space inside of a container and similar to liquids and solids, gases must take up space and have mass. So this would also go down. I'm not going to write gases over here on the left, but I would if I were you. Some of us have done so. So we have matter, and we discussed as 3 different forms of matter. Really quick, Layla was one.
Solid.
We have solid. Isaac, what's another?
Liquid.
We have liquid. And Alma? Gas. What do all 3 have in common? Juanita?
They all take up space and they all have mass.
Great. So what does that mean when it comes to matter? So what must be true about matter? Kai?
That was all.
Matter's all around you, yes. What else must be true about matter if we have 3 different forms and they all have that in common? Alice?
Anything that takes up space is matter.
There we go. And mass. So So we have our three different forms of matter. Each of those forms has one thing in common: to take up space and have mass. Therefore, matter must take up space and have mass. In the last class, I had somebody ask, what about antimatter? To be honest with you, I don't know much about antimatter, but I don't want to build on that. Isaac, go ahead if you have a comment about antimatter.
Antimatter is basically the opposite of matter. And if antimatter ever touches or even gets near normal matter, it can cause an explosion about the size of the U.S. state of Alaska.
Okay, so probably just a little bit of so antimatter is very volatile, it's dangerous, it's not stable.
And some people, and the U.S., Russia, and many other countries are trying to build a nuclear bomb out of antimatter. And they say it could be a deadly weapon, in which they could probably kill the entire planet if they use too much.
So antimatter is, again, highly unstable. Again, I'm not going to comment much about antimatter. I don't know much about antimatter, but what I have heard is that it can be used for energy as well. So there are some benefits to it if we're able to harness its potential. We'll move on from there. Thank you, Isaac. Okay. So here we have water is matter. Yes, let's discuss everything is matter, so water too must be matter. And we're familiar with the three different shapes that it comes in, yes. We're familiar with this one. When we freeze it, water becomes what? A solid ice cube. So what I want you to take away from this image, and what I will do, is I will draw this image in your notes. So I'm going to erase this now. Forms of matter. Okay, so if we're drawing this, what I want you to understand or take away from this picture is these little balls, circles, they're molecules. So if each one of these molecules is H2O because it's water, what do we notice about those molecules in the solid form? Alexa?
They're all stuck together.
They're stuck together. The forms in the solid are stuck together, they're not moving. And what about their shape? Alessandra? It takes a very definitive shape, form, yes. In this case, it would be an ice cube. Well, water, when you add temperature to it, or energy. I'll go back to this E word, keep it in mind. When we add energy, these molecules become excited, they start moving. All of a sudden they go from being stuck together to a little bit loose. Notice they're not completely apart, they're not completely separated, but they're able to freely move now. So then we get this liquid, and then if we continue to add more energy after, or we continue to add more heat or energy, all of a sudden our little molecules become so excited, they move far, far away from each other. And we get water vapor, gas, as it evaporates. So we have our solid, we have our liquid, which is slightly apart, but still kind of together. And then we have our gas, which is fully apart.
Sure, Collective.
Yes.
Can you submit a second period attendance?
Yes, sorry. I did.
Thank you.